Today's lesson is writing equations using point-slope form. Point-slope form is y minus y1 equals m times x with a quantity of x minus x1. M is your slope still. x1 and y1 are the x and y value of the given point, and then x and y are going to stay as your variables. We're going to plug in the information we have. If it asks for its in point-slope form, we're just going to leave it like this. If it asks for slope-intercept, which is y equals mx plus b, we will solve the equation and get y by itself. So the first problem is write the equation in point-slope form given a point and the slope. So my form again, I'll write it y minus y1 equals m times x minus x1. My m is negative 1/2, so negative 1/2 goes here. My x1 is 1, so x minus 1. And my y1 is 6, so y minus 6. And that's point-slope form. I can leave it. So it's important to pay attention to the directions. This says in point-slope form, so all I have to do is plug in my information. Number 2, if m is 3/5 and my point is 5, 8, it's y minus, this is y1, 8, equals m 3/5 times x minus x1, which is 5. And again, this is the point-slope form. So I'm done. Now, what if it said, write it in slope-intercept? Instead, we're going to use point-slope form, and we're going to distribute. Okay, so this is a little side note. Some of the problems on the homework will ask you to leave it in point-slope form. Some of them will ask you to put it in the points or in the slope-intercept. So I'm going to distribute my negative 1/2. I get y minus 6 equals negative 1/2 x. Negative 1/2 times x is negative 1/2 x. Negative 1/2 times negative 1 is plus 1/2. And then I want to get y by itself. So I'm going to add the 6 to both sides. And we get y minus 6, y by itself because this is 0. So y equals negative 1/2 x plus 6 and 1/2. And if I want to make that improper, I can. 2 times the whole number is 6 plus 1 is 13. So this would be 13/2 negative 1/2 x equals y. Either one of these are correct answers in slope-intercept form. Number 2, if I wanted to put it into slope-intercept form, again I have to distribute my 3/5. So I get y minus 8 equals 3/5 x. 3/5 is positive, 5 is negative, so it's going to be minus. And let's just do a little multiplication over here. 3/5 times, when I multiply a fraction times a whole number, I put the whole number over 1. I can cancel my 5s and make that 3 over 1, or I can make it 15 over 5, which is 3. Multiply the top, multiply the bottom when we're multiplying fractions. So minus 3, and then I want to get y by itself, so I'm going to plus 8 to both sides. And y equals 3/5 x plus negative 3 plus 8 is 5. That's my final answer in slope-intercept form. So this is point slope, and this form is slope-intercept when y is by itself. Now what if we have 2 points instead of a point and the slope? On a graph, we can find the slope by using the rise over the run. I'm going to start at the leftmost point here. Start here. I'm going to count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it went up 12. That's my rise. And I'm going over, let's count this, 1, 2, 3, 4, 5, 6. my run is 6. So my slope is 12 rise over 6 run, which reduces to 2. Now in this one, I can use any point I want. I can use the 4, 6 or the -2, -6. I kind of prefer the positive numbers, so let's use that one. Y minus y1, that's 6, equals m, which is 2, times x minus x1 is the 4. So in point slope form, that's one of the equations. You could also use the other point, y minus -6 equals 2 times x minus -2, which becomes y plus 6 equals 2 times x plus 2. Now, they look like different equations, but they represent the same line because this line passes through either of those points, the -2, -6, the 4 and 6, and has a slope of 2. We're just using a different point to be the identifier. But what happens when we solve for y and put it in slope-intercept form, and this is why we like slope-intercept form better, if I distribute, I get y minus 6 equals 2x minus 8, and we add 6, and we get y equals 2x minus 2. Okay, do we get the same thing with the equation down here? We should, because it's the same line. Distribute the 2, we get y plus 6 plus 6 equals 2x plus 4. Subtract my 6, get y by itself, and y equals 2x minus 2. Same equation, but a different way to get there, so that is our line. And even if you look at the graph, we can see that our y-intercept here is -2, and then the slope was up 2 over 1, up 2 over 1, so that describes the same line. So pay attention, right? This says use point slope form to write the equation in slope-intercept form, so my final answer needs to be y equals mx plus b form. Now what if it's in function notation or just giving you 2 points? Remember that function notation can be written as an ordered pair, 8, -1 and 6, 0. Well, I need to find the slope now. Remember our slope formula, m equals y2 minus y1 divided by x2 minus x1. So that's 0 minus -1 over 6 minus 8, which is 0 plus 1, so that's 1 over -2, which we'll write as -1/2. So that's my slope, and then I can use either point. I like a point with 0 in it here. Y minus 0 equals -1/2 times x minus x1, which is 6. Now again, it does not matter which point I use. As I showed you on the last slide, we get the same final answer, so it's okay to pick a point that might be a little bit easier. When we have 0 in the mix, it always makes things easier. So that's y minus 0 is just y equals -1/2 x, and -1/2 times -6, put a 1 over it so we can multiply straight across. We get positive 6 over 2 is plus 3. And that's our final answer, y equals -1/2 x plus 3. And then if you're given 2 points in your point form, let's find our slope. M equals 10 minus 4 over 3 minus 1. M equals 6 over 2. M equals 3. And then I can use either point. Y minus 4 equals m, 3, times x minus x1, which is 1 in this point, right? x1, y1, this is the point I'm going to use. X minus 1, and then distribute. I get y equals y minus 4 equals 3x minus 3. Don't forget to multiply to both terms inside those parentheses. That's a huge source of error. add 4 to get y by itself, and y equals 3x plus 1, and that's our final answer. Lastly, we want to look at a word problem. To ride a best-in-town taxi, you pay a start fee and a mileage fee. The table shows the total cost of a taxi ride for different distances. Can the situation be modeled by a linear equation? Explain, and if possible, write a linear model that represents the cost as a function of the number of miles. Oh, that's a lot. So the first question is, can the situation be modeled by a linear equation? To figure that out, we need to know if we have the same slope between each of these points. If we do, and that slope is constant, then it's linear. If not, it's not linear, and then we have to, we can't use mx plus b or linear equations. So we're going to find the slope here, y2 minus y1. I'm going to do 23 minus 13 over 8 minus 4. That's 10 over 4, which reduces to 5 halves. So that's the slope between the first two. The next two is 28 minus 23 over 10 minus 8. So I'm doing these two next. And then that's 5 over 2, same slope. So far it's looking good. Now the last two have to match. 33 minus 28 over 12 minus 10 is also 5 over 2. So because all my slopes are the same here, it's linear. And we know m is 5 halves. And if we know m is 5 halves and we know one of the points, I can use any of these 4 points. We're going to plug it in to our slope point slope form. Y minus y1 equals m times x minus x1. And again, x1 and y1 can be any of the points we want. So I'm going to do y minus 13. I'm going to use 13 and 4 equals m, 5 halves, times x minus 4. And y minus 13 equals 5 halves x. And 5 halves times 4 over 1, that's 20 over 2. Multiply straight across, or you can cross cancel. And 20 over 2 is 10. So minus 10, because it's a positive 5 halves and a negative 4. Then we'll add 13. And y equals 5 halves x plus 3, which means that the start fee is the $3. Our start fee is $3, and our mileage fee is 5 halves, which reduces to 2.5. So it's $2.50 per mile, starting with a $3 start fee, and that's how taxis work.